Hello friends, today we're going to be solving multi-step equations. So this time we will have more than one step to solve for a variable. Of course, I have my steps up here on the top if you want to take a moment and go back through and make sure that you know what each of these terms means. That's going to be very important. All right, so let's start with example one. In example one, we have 2 and 5/10 x minus 13 equals 2. And so what I'm looking at is I have a variable with a coefficient and I have a constant. So the first thing I need to do is I need to isolate that variable with coefficient. I'm going to do that by using inverse operations. What I see is subtracting. The inverse operation to subtraction is adding. So I'm going to add 13 in order to make a zero pair. Whatever I do to one side, I need to do to the other because this is a balanced equation. And just like in science, if I add to one side of a balanced scale, I have to add equally to the other. So negative 13 plus 13 equals 0. What I'm left on the left-hand side is 2 and 5/10 x. And on the right-hand side, I have 2 plus 13, which is 15. Now I have a variable with the coefficient isolated on the left. I need to isolate the variable even farther by removing the coefficient. In order to remove that coefficient, I need to use my inverse operations again. What I see, because it's smashed up next to each other, I know in invisible math that means that it's multiplying. So if I see multiplying, the inverse is division. So I'm going to divide by that coefficient on both sides because it is a balanced equation. 2 and 5/10 divided by 2 and 5/10 is 1. So on the left, I'm left with 1x. And I have a division problem, 15 divided by 2 and 5/10. To make this easier to think about, I'm going to move my place value 25. So 150 divided by 25. I know that 4 25s is 100. 2 25s is 50. So this should be 6 25s. 6 times 5 is 30. Regroup my 3. 12 and 3 is 15. I subtract and I have nothing left. So I believe that my x is a positive 6. Now to check this, I'm going to rewrite my original equation just in case. Oops, there I go. I'm making a boo-boo. Not a 12. This should actually be 13. My mistake? All right, so my original equation is correct. At this point, I'm going to use substitution to check my work. So wherever I see x, I'm going to write a 6 minus 13. I believe, I'm not positive yet because I haven't worked it out, is 2. I know that I'm going to need my order of operations, parentheses, exponents, multiply, divide, add, subtract, to make sure that I'm doing this correctly. So I don't have any parentheses, I do have parentheses. 2 and 5/10 times 6. So again, not something I would know in my head. I need to come over here and work it out. 5 times 6 is 30. 12 and 3 is 15. I have one place value, so that would be 15 minus 13, I believe, should equal 2. 15 minus 13 is, in fact, 2. That checks out. So my solution is correct. Let's take a look at example 2. Example 2 looks a little more messy. Negative 12 equals 9x minus 6x plus 15. So the very first thing that I'm going to do is I'm going to simplify by combining like terms. My like terms is this 9x and this negative 6x. And I know they're like terms because they are both a coefficient with the variable x. 15 does not have that variable, so this is a constant. That is not a like term to these over here. Negative x minus 6x would be 3x, and my constant stays the same. All right, so now I'm looking a little bit more like what I started with in example 2. I need to isolate my variable. I'm going to do that by inverse operations. What I see is adding, so I'm going to subtract that constant of 15 15 minus 15 is 0. So on the right-hand side, I'm left with 3x. Negative 12 minus 15 is negative 27. Now I need to isolate my variable by removing the coefficient. In order to do that, I'm going to use inverse operations again. What I see is this coefficient smashed right up next to this variable. And I know that that means that's multiplying. So if I see multiplying, I'm going to divide by that coefficient of 3. Of course, I'm going to do the same thing to both sides so that we keep our balanced equation. Negative 27 divided by 3. Well, I know a negative divided by a positive is a negative. 27 divided by 3 is 9. So I believe that my solution is negative 9. All right. So now when I go to check, I'm going to go to that original equation. And the reason I'm doing that is because if I made a boo-boo right here and I just substituted into this one, I could potentially be incorrect in my solution. So I'm going to go to my original equation. Negative 12 equals 9x minus 6x plus 15. And now whenever I see an x, I'm going to substitute in a negative 9. So negative 12 equals 9 times negative 9 minus 6 times negative 9 plus 15. And I think that's correct, so I'm going to put my question mark. Negative 12 doesn't do anything yet. I need to simplify it over here on the right. I don't have really parentheses because really what we're seeing here is multiplication. I don't have exponents, so let's go ahead with 9 times a negative 9. Positive times negative is a positive. 9 times 9 is 81. Minus 6 times a negative. So positive times a negative is a negative. 6 times 9 is 54 plus 15. All right, well, let's clean that up a little bit. We have a negative 12, I think, is equal to negative 81, negative, negative, so that makes this a positive 54 plus 15. And you can choose to combine like terms whatever way you like. I prefer to add myself. So negative 12, I think, equals a negative 81 plus 54 and 15 would be 69. Oh, that went weird, sorry. Negative 12, negative 81 plus 69. So I would need 2 more to the 9 to get to 1, and then 10 more to get from 70 to 80. So it's a negative 12. It does check out. So my solution is that x is equal to negative 9. All right. Let's slide on down to example 3. Here we have that distributive property. I know I'm going to have to distribute because that 2 is pushed right up against those parentheses. So I have 2 times 1 is 2, minus 2 times x is 2x. That constant is not related to that, so it just stays put at a positive 3 equals a negative 8. Here I need to combine like terms. So this 2 is a constant and this 3 is a constant. So let's pull those together. Positive 2 plus a positive 3 is positive 5. So I have negative 2x plus a positive 5 equals negative 8. I'm going to isolate my coefficient and variable by subtracting 5 using inverse operations. Whatever I do to one side, I do to the other. So I have a negative 2x equals negative 8 minus 5 is negative 13. Inverse operations, I see multiplying, I'm going to divide by a negative 2. And I have x equals, well, let's see, half of 13. Because negative divided by a negative is positive, so I know it's going to stay positive. Half of 12 is 6. Half of 1 is a half, so this would be a positive 6 and a half. So this is one way that you could solve it. Obviously, I want to check. Just a second. But there is another way that you could do this. So you don't have to distribute first because you have this constant. The first thing you could do is that you could remove the constant. I see adding, so I'm going to subtract 3 from both sides. 3 minus 3 is 0. 8, negative 8 minus a negative 3 is a negative 11. So 2 times 1 minus x equals a negative 11. So if you want to remove that constant first, get it out of the way, that's fine too. At this point, we would distribute. 2 times 1 is 2, minus 2 times x is 2x, equals a negative 11. Isolate the variable by inverse operations. I have a positive 2, so I'm going to subtract 2 from both sides. 2 minus 2 is 0. I have a negative 2x equals negative 11 minus 2 is negative 13. Remove the coefficient using inverse operations. Divide by a negative 2 on both sides. And x is equal to 6 and 5/10. Either way, you're going to get the same answer. You have to choose which way makes the most sense for you. Of course, I'm going to check my work. Going back to that original equation, 2 times 1 minus x plus 3 equals a negative 8. And where I see x, I'm going to add a positive 6 and 5/10. So 2 times 1 minus 6 and 5/10 plus 3 equals a negative 8. Again, you could choose to distribute first and then simplify, or you can simplify first and then distribute. 2 times negative 5 and 5/10 plus 3, that's a weird 3, sorry, equals a negative 8. Again, I'm questioning this. This is my work. 2 times a negative 5 and 5/10 would be negative 11 plus 3 could equal negative 8. Negative 11 plus 3 does actually equal a negative 8. And so my solution or solutions are correct. At this point, pause the video and I will see you back after you do the you try 1 and you try 2. And we're back. How did you do? Were you comfortable? Did you have some questions? Make sure if you have questions that you ask tomorrow in class. Let's take a look at how you did. You were isolating the coefficient and variable by using inverse operations. 3w equals 12. You removed the coefficient using inverse operations. W equals 4. Of course, you were checking your work. 3w plus 7 equals 19. 3 times 4 plus 7, I believe, equals 19. 3 times 4 is 12, plus 7 probably equals 19. I know you've probably figured that out, that 19 does equal 19. So your solution for you try 1 is W equals 4. Great job. Okay, you try 2. In order to isolate this variable, you had to multiply both sides by 5. Remember that fraction bar means to divide. So 5 times 1/5 equals 1. I'm left with h plus 6. That was a weird looking h. Sorry about that. 2 times 5 is 10. Isolate the variable using inverse operations. Subtract 6 from both sides. And I have h is equal to positive 4. Again, we're going to check. H plus 6 divided by 5 equals 2. Wherever I see h, I'm going to write a 4 plus 6 divided by 5, I think equals 2. 4 and 6 are 10. 10 divided by 5, I believe, equals 2. And 10 divided by 5 is 2. So it is actually that h is equal to 4. How did you do? Let me know tomorrow in class. You have a couple more questions to practice, and we will go over them in class in the morning. Have a great day.